So, this time I'm going to do some elimination. So what I want to do is I want to do some arithmetic to where I can easily cancel out a variable. And what looks like it's going to be the easiest variable to cancel out here? Because I want to know. All right, anyway. Joke never gets old to me. I'm going to multiply my top equation by 2, and that will help me eliminate my y's. So, I've got 4x plus 2y equals 6, and 3x minus 2y equals negative 13. The most common mistake made in elimination problems is, okay, you distribute and you get this and this, but then you forget to multiply the final term by that value. Okay, so we've eliminated our y's. We add them together. Your computer program doesn't call this elimination, it calls it addition. And you are adding the two equations together, but I think the term elimination is a better term for what's happening here. So we end up with x equals negative 1. Again, we should, because that's what we got the last time. Well, from here, we solve it out just like we did the last problem. So 3 times negative 1 minus 2y equals negative 13. So negative 3 minus 2y equals negative 13. Negative 2y equals negative 13 plus 3, which would be negative 10. Dividing both sides by negative 2, we get 5. So we once again get the points negative 1, 5. Did any of y'all have Coach Norton for Algebra 2? If you did, you've probably seen this next method. If you didn't, you probably have not seen this method. It's called Cramer's rule. Now, to be able to do Cramer's rule, you need to know how to take the determinant of a 2 by 2 matrix. The determinant of a 2 by 2 matrix is going to be written like that. So what you do is you cross multiply and subtract. So it's A times D, upper left times lower right, minus upper right times lower left. And that's how you find the determinant of a matrix. So let's say we have negative 5, 3, negative 2, and 1, and we want to solve that determinant. Well, what would I do here? Negative 5 times 1, like I said, plus or minus negative 6. Which is, as you said, plus 6. I'll get negative 5 plus 6. And that is 1. Is there a question about that? All right. So from that, let's go back to the same problem we've been solving. Which was what? 2?
2x plus 1 equals 3. And 3x minus 2y equals negative 13.
Okay. Alright, now, if you have two lines in standard form, ax plus by equals m and cx plus dy equals n. If you have that, then you get the x coordinate by taking the determinant of, because it's x I'm solving for, I'm gonna omit the x's here, and I'm gonna plug m and n in its place. So it's gonna be m n and then b over d. Not b, I'm sorry, that's not really reading it right because it's a determinant. So b over d makes it sound more like it's a fraction, but it's not, it's a determinant. And then my y coordinate, since the y's are what I'm not using, I take my x values, which are a and c, and then in the place of where my y's would be, I put m and n. And in the denominator in both cases, I put my x's and my y's. Of course, when I say my x's and my y's, I'm talking about the coefficients that go with them. And I'm there. So it's my column of answers times my column of y's, my column of x's with my column of answers, column of x's, column of y's, column of x's, column of y's. So here, for my x coordinate, what would be my column right here?
3 and -13.
Okay, is there a question about that? All right, what would be my column here, someone else? Well, I go to my B and D. What stand in the place of my B and D? 1 and -2. 1 and -2, okay. All right, then here it's 2, 1, 3, -2. All right, my y's. And again, I could do a modified version of Cramer's rule. I could solve for x, and then when I get my x value, plug it back in for y and do that. But let's just go ahead and solve it out. All right, so A is 2. B, no, I'm sorry, C. 3. All right. And then M, 3, and N is -13, okay. And then 2, 3, 1, and -2. All right, so we're gonna do the determinants. So this, and I'm gonna write this step out. You would not have to write this step out. 3 times -2 minus 1 times -13. Again, the downward diagonal times the upward diagonal. Got 2 times -2 minus 3 times 1. And then for y, two times -13 minus 3 times 3. Let me get out of y'all's way, because I did make a better door than window. Okay, 3 times -2. -6 plus 13 over -4 minus 3. Okay. And here I have negative 26 minus 9 over negative 4 minus 3. Okay, so what's negative 6 and 13?
7.
So I have 7 over negative 7, which is, bless you, negative 1. And then I've got negative 35 over negative 7, which is 5. So once again, I get negative 1. 5 is the solution. So we've had substitution, we've had Kramer's rule, and we've had elimination. In Kramer's rule, the arithmetic's not difficult. It's just a matter of remembering the formula. And first period today when I was doing it, I had to go back. I started second guessing myself, so I had to go back and double check to make sure I had the formula right. So if it's something you don't use very often, it might not be the best way to do it, but it's another tool in that tool chest that you can use to solve it out. So we looked at 3 different ways of solving out systems of linear equations. I want to do one more thing with this. I want to do a system of equations where we have 3 equations, 3 variables. So, in my last class, I did not pick a good example to do, so I found a better example in this class. So, they're my guinea pig class, because first one I teach, 2x minus y plus z equals 7. X plus y plus 3z equals negative 9. And then 3x minus 2y minus z equals 15. Okay. And if I remember correctly, there is a Kramer's rule method of solving this out. I don't remember it, so we'll just look at elimination here. So what you do in a case like this, first off, however many variables you have, you need that number of equations to solve it out. So here we have 3 equations and we've got 3 variables, so we're good there. I'm going to pair 2 of them together. Now, I'm going to look at eliminating my y first. I think that's going to be the easiest thing to do because I have this equation here, and then these 2 equations have different signs with their y's. So what I'm probably going to do is I'm going to match these 2 together and then match these 2 together. That way my y's are a little bit easier to remove. So I'm going to pair 2 of the equations, the 3 variables together, 2 different pairs of them, and eliminate a variable each way, and then I have 2 equations with 2 variables after that. So here we go. We've got 2x minus y plus z equals 7, and then x plus y plus 3z equals negative 9. So like I said, if I just add this equation to this equation, my y's will cancel out. So I get 3x, okay, my y's cancel out, z and 3z is 4z, and then negative 9 and 7 is negative 2. Did I do my arithmetic correct? Because if I didn't, it's not going to show up till later on, it's going to be ugly. All right. Now I need to group these 2 together, but y will not eliminate automatically here. I'm going to need to multiply by 2 on that first equation. sometimes you'll have to multiply by both equations. Like if you've got a 3 and you're trying to cancel it with a -2, then you'd have to multiply the 3 by the 2 and the -3, or the -2 by a +3 or whatever. So sometimes you have to multiply by both equations. All right, so from here, I'm gonna go out to the side and rewrite this. You don't have to do this. You could do the arithmetic from here if you wanted to. All right, adding those together, 2x and 3x is 5x. 6z and -z, and -18 and 15, -3. All right, so now I'm down to two equations with two variables. So I've got 3x plus 4z equals -2, and 5x plus 5z equals -3. So based on what I have here, I mean, neither of the variables are going to be that easy to eliminate here. What do you want to eliminate, x or z? X, okay. So I would multiply the top equation by -5, and the bottom equation by what? 3. Very good. So I get -15x minus 20z equals 10, and 15x plus 15z equals -9. I've made a mistake somewhere. Unless they made the mistake. Which, now that I think about it, I do remember that there was one problem from the past that had a mistake in it. I mean, y'all been double checking what I've done. So yeah, I think we're just gonna get a nasty answer here. So I get -5z equals 1. So z equals -1/5. Hey, how are you? Good. I'm recording this for you.
Okay.
So it's gonna be weird. I'm talking to you while you're gonna go back and watch it, and you're thinking, "Wow, is that really me he's talking to?" All right, so z equals -1/5. Now, I'm gonna take that value and I'll plug it into either this equation or this equation. Doesn't matter, let's plug it into this one. 5x plus 5 times -1/5 equals -3. So 5x minus 1 equals -3. 5x equals 2, -2. So x equals -2/5. So I've got my second variable solved for. So, let's just go to this top equation here. 2 times -2/5 minus y plus z is -1/5 equals 7. So -4/5 minus y minus 1/5 equals 7. Negative y, this would become -5/5, which would be -1. Negative y equals 8, so y equals -8. So my ordered triple, in this case, it wouldn't be an ordered pair, it'd be an ordered triple, would be -2/5, -8, -1/5. All right, so I will let y'all continue on with your assignment. I'm grading papers up here, so if y'all have any questions, don't hesitate to ask.